The signal quality of a laser vibrometry measurement depends on specific properties of the returned light. The intensity of the returned light is the primary measure and is visualized on a signal level indicator. The surface determines the spatial distribution of the backscattered light and thus the information that the photodetector can receive from its position in space. The signal-to-noise ratio thus depends on the surface properties. Our patented technology, QTec, now enables a significant improvement to the signal-to-noise ratio. Even the finest details are resolved in the measurement signal, and unambiguous data are the key to straightforward post-processing. QTec improves the results in almost any measurement and is particularly beneficial for surfaces that move laterally or rotate. QTec is faster because the average count can be drastically reduced to achieve the same signal-to-noise ratio, and easier too because it is independent of the surface properties. With QTec, we have reinvented laser vibrometry by eliminating the root cause of noise with rough surfaces, the speckle effect. On an optically smooth surface, the reflected laser light is returned without loss to the photodetector. Vibration tests in the real world are often carried out on engineered surfaces that are optically rough. Now the light is no more reflected, but scattered. It contains dark and bright speckles. The laser point now looks grainy and pattern changes with the perspective of the observer. Also, the photodetector of a laser sensor represents an observer, and while measuring vibration, the pattern and the amount of received light changes constantly. It can even drop down to zero for a very short time. Occasionally, no light returns at the photodetector. This effect can cause broadband noise and unwanted dropouts with optical measurements. Now, wouldn't it be a good idea selecting the observer perspective such that there is always a bright speckle containing all the information on the vibration in focus? QTec's heterodyne multipath interferometer provides exactly the capability to avoid reduced signal at the photodetector by using multiple detectors. Every detector represents an observer with a unique perspective and thus a unique speckle pattern. For every point in time, the signal level varies with the speckle pattern. As the pattern is random, it can be shown that the combination of the signals from the spatially distributed detectors results in a statistically stable signal level. Ultra-fast electronics in the sensor head weight the detected signals in real time, and only the best part of the signal is transferred to a common output. QTec's capability to measure independent of the surface properties makes it a safe choice for all applications, providing fast, easy, robust results. It is faster because the average count can drastically be reduced to achieve the same signal-to-noise ratio, and easier because it is independent of the surface properties, while the stable signal level facilitates decisions on the best measurement location.